A very good morning, good afternoon, good evening to all my students, participants and candidates for this course NPTEL MOOC under NPTEL MOOC, and the title of the course is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as I start for each session or class, basically this is the way I go. So, as you know, there are three main areas where the main emphasis for this course is. One is averaging technique forecasting, number two is regression models, and number three is time series analysis. And the class or the overall idea which we are covering for the last quite a few weeks is basically the area of averaging techniques and forecasting, and today is basically week 4, lecture number 18. Now, what is the coverage for this lecture? So, even though I have written that we will consider exponential smoothing, multiple adjusted parameter concept, and we will also like to go and start Holt linear method. And as you can recollect, in the last session it was basically a detailed discussion about the idea of exponential smoothing with one parameter which is adjusted. Now, the basic idea to cover the concepts of multiple parameter adjusted exponential moving average, we will consider the fact that standing today we are going to predict for the next time period, which means we already have the data for yt, the forecasted value given as ft. We also have, and naturally so, the actual value for yt minus 1 and the forecasted value of ft minus 1, and based on these 4 values we are going to forecast for the next time period, which will be given by ft plus 1. So, if I consider that, so what we plan to do is this: we want to basically find out ft plus 1, and if you remember, for the constant or non-adaptive multi-parameter exponential smoothing concept, we had parameters alpha 1, alpha 2, alpha 3, alpha 4 corresponding to yt, ft, yt minus 1, ft minus 1. We will follow the same concept, but with an added concept being there that these alpha 1, alpha 2, alpha 3, alpha 4 are being adjusted with respect to how the overall forecast is being made from time period to time period. So, based on that idea, the discussion would be, I will just highlight the main points without going to the detailed problem solving, because for any problem, if you remember, we have already considered the moving average, different ways of moving average. We have already covered the concept of exponential smoothing, single parameter, multi-parameter, where the parameters are constant. We have already considered in details the adaptive single parameter exponential smoothing. So, considering that we can extend, but and also the fact we have to cover a lot of more topics, I will request the students to just go through the ideas, because until unless in-depth analysis is required, this concept of multi-parameter adaptive exponential smoothing may not be required, because moving average, adaptive exponential smoothing, non-adaptive exponential smoothing, then the later part of Holt linear method, which we will try to discuss today, the concept of Holt winter method, considering the multiplicative seasonality, additive seasonality is more than sufficient to tackle maximum of the problems in both theory as well in practical situations. For multiple adaptive exponential smoothing method, considering, so this is G here, considering there are 4 adaptive parameters, which are alpha 1, even though I have written an alpha 1, later on we will basically replace that with alpha 1 t, because it is dependent on time. Alpha 1 is for t, y t. So, I will use a different color, it will be alpha 1 comma t f y t. Then you have alpha 2 for f t. So, let me use the orange color, alpha 2 t f t. Then it is alpha 3 for y t minus 1, which is alpha 3 t, and use a green color now. And the final one is basically alpha 4 into f t minus 1. So, alpha 4 comma t, this is suffix, that means 4 comma t is f t minus 1. So, there are 4 parameters all adjusted, and we are giving weightages to y t, f t, y t minus 1, f t minus 1. So, we define the weights. So, alpha I weights for forecasting, which I have already mentioned here, corresponding to I is equal to 1, 2, 3, 4, which we have already done. Now, if you remember, there was a concept of beta also in single adaptive exponential smoothing. Here, betas are the weights for the errors. So, alphas are the weights for the to help for forecasting, while beta are the weights for the errors. Again, beta 1, beta 2, beta 3, beta 4. Remember, beta 1, beta 2, beta 3, beta 4 are not changing. They will be fixed based on how the alphas change, then you find out the error and try to utilize the different matrix like the U statistics, the minimum squared error, the mean absolute error, then the percentage error, weighted percentage error, weighted absolute error, weighted mean square error, U statistics, all these things can be utilized to come up with the best model. And if you remember, best model in the sense that if you have seen in the last class that for all the matrix you may get not a single model, not one model is best. There can be multiple models or more than one model which can be based on the matrix which you are utilizing. Remember that, and we have shown that with an example with the values. AIs, consider j is equal to 1, 2, 3, 4 are the smoothing error, and the corresponding m are the absolute smoothing error for j is equal to 1, 2, 3, 4. Now, this is how the diagrammatic representation would work. So, consider in all the diagrams I have drawn y along the horizontal axis, and parallel to that you had f. Here I am just drawing it vertically. So, if I consider what do I have is the y t minus k, k can be any value. So, how long we want to go back in the past, and it goes one step at a time, y t minus 1, y t minus 1 plus 1. So, this t minus 1, t minus k plus 1, t minus k plus 2 are all in the suffix of y. So, again I am reading y t minus k plus 1, y t minus k plus 2, and it goes on till y t minus k plus 5. Corresponding to each y, you have the f, which is written on the right hand side, again vertically. So, they are given for the forecasted value for y t minus k is f t minus k. Similarly, the forecasted value for y t minus k plus 2 is given by f t minus k plus 2. Similarly, the forecasted value for y t minus k plus 5 is given by f t minus k plus 5. Now, why these arrows and different colors? The concept is that you are taking 4 different values to forecast for the t plus 1th time, and the forecast is given by f t plus 1. Hence, the 4 values which are being utilized and they are being multiplied by the corresponding adaptive parameters, which are alpha 1 t, alpha 2 t, alpha 3 t and alpha 4 t, and the 4 values which are being utilized are, I will again repeat, which I mentioned few minutes back, but still I will again mention it. They are y t, f t, y t minus 1, f t minus 1. So, if I see the red combination, there are 4 values here. I remove this black color. So, the coloring values are for y t minus 1, f t minus 1. So, here actually you will have the starting values as alpha 1 comma t. For f t minus k, it will be alpha 2 comma t. Similarly, the third value is y t minus k plus 1. So, that will have a parameter alpha 3 comma t, and the last value which you will have is basically f t minus k plus 1, the corresponding parameter is alpha 4 t. So, utilizing that, you would basically predict the value for the next time period would be f t minus k plus 2. You are going one step forward. Similarly, I will utilize in the second stage y t minus k plus 2, f t minus k plus 2, y t minus k plus 3, f t minus k plus 3 with multiplied by the corresponding adaptive parameters, and then try to basically find out the forecasted value which would be given by f t minus k plus 4, and I will proceed accordingly. And obviously, the main one constraint which will always be true is the fact that the sum of the parameters, whether they are changing or they were not changing for the non-adaptive case, the sum would always be 1. That is point 1. Point number 2, if you remember, for the multiple non-adaptive parameters exponential smoothing, I considered alpha 1, and rightly so, alpha 1 is greater than equal to alpha 2 is greater than equal to alpha 3 is greater than equal to alpha 4, because the weights which you will give for the immediate actual value, which is y t, would be the highest. Similarly, the weight for the corresponding forecasted value would be the second highest. Then the value of alpha 3 would be for y t minus 1 and alpha 4 would be the value for f t minus 1. So, that assumption would also hold true, that the sum of the parameters is 1 always. Now, what is required? So, in this table I have just given the schematic sketch, in the sense with the formulas, not any values, because if you follow this algorithm, follow this rule, the values can be calculated accordingly. The first column is basically y, which is actual value. Second column is basically f, which is predicted value. Third column is the error based on which you will work. So, that is the difference between y and f for the corresponding time period. The next 3 columns are required to find out the value of a, because if you remember, they would be 4 values of a, which are for this case a t minus 3, a t minus 2, a t minus 1, a t, and they are given by the corresponding weights of beta 4 into e t minus 3. So, beta 4 I am considering as the weights being assigned to the error of time period t minus 3, which is the first row, plus 1 minus. So, this would basically be, if this would be all with the corresponding suffix. Sorry, so I will correct it. So, there would be multiplied by 1 minus the corresponding value of beta into the a value. So, if you remember, the concept of a and m were based on the concept of errors and smoothing errors, adjuster smoothing errors. Then I have the values of m, and m is basically given here, the beta values are fine. So, m would basically be the weighted sum of the error of time period t minus 3 and m t minus 4, which is one step backward. So, based on that I find out all the values of fifth column, and remember at each step as we proceed we will be able to find out alpha values accordingly as it keeps changing. Now, as for the starting values, if you remember, the starting values were marked with dark blue both in the Excel sheet as well as in the PPT slide. So, what are the starting values? So, here is the first equation which we have mentioned, I am again mentioning. They are the corresponding multiple adaptive parameter formula to forecast f t plus 1 based on y t, f t, y t minus 1, f t minus 1. Here the parameters are alpha 1, alpha 2, alpha 3, alpha 4, but obviously with a suffix. Remember that. Now, assumption, I will come to the assumption before coming to the starting values. The second last assumption is true because the sum of the adaptive parameters alpha is 1. Also, it is true that the values of beta 1, beta 2, beta 3 is also 1, and the condition that beta 1 is greater than beta 2 is greater than beta 3 is greater than beta 4 obviously comes from the same concept by the idea that how you are putting the weights alpha 1 to alpha 4, and which is just being highlighted by me here. Alpha 1 is greater than alpha 2 is greater than alpha 3 is greater than alpha 4. Starting values, I will mark them one at a time with the red color. AT and MT is equal to 0 as we did it. AT minus 1, MT minus 1 is also 0. Similarly, for AT minus 2, MT minus 2 and AT minus 3, MT minus 3. Basically, the starting values of the errors and the smoothened errors would basically be considered 0. Then what also assumption is that if you remember, and that is very intuitive, if you remember we said that for the starting value we will consider either for one parameter or multiple parameters, both adaptive and non-adaptive, is the fact that the actual value for today would be the best forecast for the forecasted value for the next day, which means f t plus 1 would be best given by y t, this one which I am putting a double tick mark, or I can change the color. So, the confusion does not remain amongst any of the participants. So, I am putting the color green here. Similarly, if I go back, y t minus 1 would be the best forecast for f t, which I am putting a blue tick mark. And if I consider that concept to be true, so you will have y t minus 2 is equal to f t minus 1. That means, the actual value for t minus 2th time is the forecasted value for the next time, which is t minus 1, because I am proceeding one step at a time. And last but not the least, I would have y t minus 3 is equal to f t minus 2. So, utilizing these values you can basically frame a problem, and the question can also arise that can we have such constraints of different varieties, like you have the constraints like about alpha, you have the constraints about beta. Obviously, you can have different constraints depending on the practical situation, and we will incorporate that in the model for the multiple adaptive exponential smoothing model. Now, we will have the diagram, schematic diagrams which I have been drawing. I will try to make it much more clear in this slide. So, you have basically steps as you proceed. So, you are here based on which from where you are standing and you want to forecast. So, that is basically given as the time period t. Here it is t, I will mark with the blue. The next time period obviously would be, I will mark with the red color, is t minus 1. So, I will basically utilize the values here. then t minus 2, t minus 3 and it will continue. So, if I consider the time frame, here you are basically writing the value of the actual value y t, and if you go one step at a time back, that means on to my left is the past, on to my right is the future. So, you have, I will put the red tick mark y t minus 1, y t minus 2 till y t minus n plus 1. Now, in the case of, in the last example I have taken k. So, here it is taken n, but I purposefully omitted considering n because n was basically the sample size based on which we are trying to forecast. And the corresponding forecasted values would basically be that if I have the past data which is in step D, I will come to step C later on. So, if you have the past data, I will use green color, you have f t corresponding to f t minus 1, t minus 2 till f t minus n plus 1. And having said that, you want to basically forecast some time periods down into the future, and here it is. You would like to predict standing today basically for t plus 1 and such m time periods ahead. So, here it is given the forecasted value for such time periods ahead, I will use the orange color. So, this is f t plus 1, f t plus 2 and it will go to f t plus m, that means m time periods ahead, which I am highlighting now, and this we have done time and again. The fitting the error basically would be based on the idea we have already considered or we have been saying, the MSc, MAD, weighted MSc, weighted MAD, use statistics and then percentage error, weighted percentage error, and based on that we find out the model. This is just a repetition, but I thought I will just discuss it here. The time series for interest is divided into two parts. So, as now, why I am mentioning that for all the cases our sample size was small. So, we just gave you how you will try to utilize to find out the best model. So, given the best model you have already found out, I want to basically utilize for the future data. That means, initially there would be a training set on based on which you will train and find out which model gives you the best error in the sense the least error. And once you are certain with the model, you will try to basically utilize that for the testing set. So, consider if you have a big data set, you can proportionally divide the training set and the testing set based on a thumb rule like 70%, 30%, 60%, 40%. So, there is no fixed as such percentage based on which you divide. The time series of interest is divided into two parts, an initialization set and a testing set, which I said. So, that an evaluation of a forecasting method can be conducted and then tested. A forecasting method is chosen from a list of possible methods. The initialization data set is used to get the forecasting method started, which I mentioned. Estimates of any trend components, seasonal components and parameter values which need to be found out are calculated. The method is applied to the testing set later on to see how well it does on the data that were not used in the estimation process or not used in the testing phase in order to estimate the components of the model. After each forecast, the forecasting error is determined, and over the complete test set, certain accuracy measurements are determined. This stage is an iterative process because you proceed one step at a time. Hence, modification, initialization and subsequent search for the optimal parameters are possible. Finally, the forecasting method is appraised, analyzed and decided, and then a decision is taken as to its suitability for various kinds of data patterns and how they can the forecast can be done much more accurately. Now, we will start another method and it will take time because there will be lot of slow progress using the Excel sheet, that is known as the Holt-Niño method. So, Holt-Niño method is different from the later method which is Holt-Winter method. So, Holt linear method has two important components and which are highlighted in this slide and in blue. So, there are two components, one is based on the level, that is the local mean at which point you should concentrate and start off your model, that is point 1. And point number 2 is that based on the starting point you want to find out that what is the trend, what is the average rate of increase. So, I will try to draw a diagram very simply with an x axis and y axis denoted, where along the x axis you have the time and along the y axis you have the value of f or y, both are being plotted. But I will only draw the concept of y. So, I will take 3 different colors. So, consider the data set is like this. Another one in the same, the data set is like this, or consider the data set is like this. Now, I will mark them as D3. D3 is the data set, not the concept of D which was utilized in one of the problem where D was equal to Y. No, just I am denoting D3 as the data set 3, data set 2, and you have data set 1. Now, if you remember the first point, based on a level local mean at that point which you can concentrate from where you want to start. So, that point would be denoted by this, which is what the idea is about the level, at what level I am starting. So, if I was basically starting from the red line at this point, so that would be the level at which point I am starting and trying to utilize the Holt linear method. Now, consider the level is given for all these violet, red and green, which are corresponding data set D3, D2, D1 respectively. So, based on that I try to find out the trend. Now, trend for each data set is different, which I will draw. So, if I draw the trend for the violet one, which is data set 3, I am drawing the trend in the hashed line. So, this is the trend. If I draw the trend for the green red one, the trend is this. If I draw the trend for the green line or data set D1, the trend is this. So, even if the starting value or the level is same for 3 data sets, the trends are different, and that is what is the main focus of the Holt linear method. So, considering that we have almost exhausted about 29 minutes for this class, so I would request that I stop here with your permission and consider this same slide in the next class and continue discussing in detail Holt linear method in all its implications. Thank you very much and have a nice day.